Thanks, Maddie. Hello, good afternoon, everyone. Thank you for joining today's webinar on data analytics, building your analytics strategy. My name is Jesse Taylor, and I'm a data analytics focus area lead at Elire, specializing in data visualization and data engineering. I have about 10 years combined experience using tools such as Tableau, PowerBI, Ultrix, Kibana, DataStage, Informatica, and so on. So today we'll be discussing data analytics, building a strategy within your organization. So what I'll be covering today is developing a data analytics strategy. We'll then review some industry use cases. Then we'll cover a few leading data visualization tools such as Tableau, Power BI, and Kibana. So developing a data analytics strategy.
All right, you should see our first poll question pop up. Do you currently have a data analytics or visualization strategy in place? Yes, we have a mature process. Yes, but it's limited. No, but working on a strategy. No, unsure of where to start. And then what is data analytics and strategy? So go ahead and get those answers submitted. All right, I'll give people about 20 more seconds. And it looks like most people are saying no, but they're working on a data analytics strategy with, yeah, that being 43% of people.
Sounds good. Are we good to move, Maddie?
Yep, we can go ahead and move on.
Sounds good. All right, so what is data analytics? Data analytics in general is the process of examining, cleaning, transforming, and modeling data to extract valuable insights. Pretty much data analytics, it converts data into actionable insights, which includes a range of tools, technologies, and processes used to find trends and solve problems by using data. There are different types of data analytics. So there is descriptive analytics, which pretty much summarizes historical data to provide insight into what has happened in the past. There is diagnostic analytics, which simply is analytics that focuses on understanding certain events occurred by analyzing patterns and relationships in data. And there's predictive analytics, which uses statistical algorithms and machine learning techniques to identify future trends and outcomes based on historical data. We also have, lastly, prescriptive analytics, which recommends actions to optimize outcomes, providing decision makers with actionable insights. So why data analytics, or what is the importance of data analytics? Data analytics help drive informed decision making, uncovering pattern and gaining competitive advantage. Data analytics is also important to understand trends, patterns, from massive amounts of data that are being collected, and it helps optimize business performance, forecast future trends, and understand your businesses as well as reduce cost. So moving on, why in detail, why do we need to have a data analytics, or why should somebody be interested in data analytics? One of the few reasons is number one, data explosion. So coping with increasing volume and velocity and variety of data. So pretty much data explosion is the rapid and exponential growth of data in terms of volume, variety, and velocity. It is the extraordinary increase in the amount of digital data generated and collected across various platforms, devices, and so on. Some of these devices and platforms are digital transformation, Internet of Things, social media and online platforms, advanced technologies, mobile devices, business operations, data replication, and backups. These amount to millions and millions, billions of records each and every day. So pretty much there is that data explosion, which analytics come into place in order to resolve that. Another reason too for data analytics is business intelligence, which is simply leveraging data for strategic advantage. And this is where set of processes, technologies, and tools help organizations gather, analyze, present data, and support better business decision. The core objective of business intelligence is to convert raw data into meaningful insights, enabling businesses to make informed decisions and operational decisions. With data analytics, there are a few aspects um, of business intelligence, which is pretty much the data collection, which is the ETL, extract, transform, and load. There's data analysis, there's data visualization, predictive analytics, data warehousing, and performance monitoring. These all form under business intelligence. Then lastly, we have the economic impact of the analytics, how analytics contribute to the economic growth. So this is where the positive influence and contributions that is that the data analytics can have on various aspects of the economy. This impact can be observed across industries, businesses, and even societal level. So moving on, what are some of the key components of data analytics? So the first one we have is data collection, which is gathering relevant data from diverse sources. And this is pretty much like the process of capturing information from various sources for the purpose of analysis, interpretation, and decision making. It is really the fundamental step in the data lifecycle, providing raw materials from which insight and knowledge can be derived. Data collection can take various forms depending on the nature of the information needed and the context of the collection efforts that's needed. The next component that we have is data processing. And as we mentioned, data processing is simply manipulation, organization, and transformation of raw data into meaningful information through a systematic and structured set of operations. This, this process involves various steps to convert data into a format that can be analyzed, interpreted, and used for decision making. Data processing is a critical component of the broader data lifecycle and also includes several stages, which we are not going to get into it today. Another set of components of data analytics is the data analysis piece of things, which is simply employing statistical methods and machine learning algorithms. This process inspects, cleans, transforms, and model data to extract meaningful information, draw conclusion, and support decision making. It involves a variety of techniques and methods for discovering patterns, trends, relationships, and insights within data. The goal of data analysis is to derive actionable information from raw data, helping individuals and organizations make informed decisions. Then lastly, we have data visualization. Data visualization is simply communicating insights through charts, graphs, and dashboards. Today, we're going to focus more on data visualization, and we'll talk more in details within the next coming slides. All right, so what is data visualization? Data visualization is the representation of data in a graphical or visual format, such as charts, graphs, and maps, to help users understand complex patterns, trends, and insights in data. The primary goal of data visualization is to present information in a way that is easy to understand, allowing for a quicker and more effective decision making. Within data visualization, I'm pretty sure you all have some kind of Excel spreadsheets that you use for pivot tables, be it like matrix tables and so on. Within data visualization, there are certain aspects that are key. Some of these are communication of the information, which is transforming raw data into visual representation that are easy to interpret. We have identification of patterns and trends, which is using the visual representation that make it easier to identify patterns, trends, correlation, and outliers in data, be it bar graphs, be it line graphs, and so on. We also have the comparison and contrast, which we use data visualization to facilitate the comparison of different data sets or variables so users can actually compare trends, proportion, relationships more effectively than the raw data can do alone. So we could use data visualization for bar graph comparison or a different comparison of some kind of measures that are key to the company or the organization. Data visualization also could be used for storytelling. So data visualization can be used to tell a compelling story about a type of data by arranging visual elements in a coherent and meaningful sequence. It helps to convey insights and findings to a broader audience. Data visualization is applied to various fields, including business, finance, healthcare, education, governments, scientific research, and many more. And a well-designed data visualization not only makes data more accessible, but also enhances the ability to derive actionable insights from the information presented. So let's get more into data visualization. Why data visualization? There are many reasons why an organization should actually employ data visualization. Some of these reasons are with data visualization, business individuals can comprehend information quickly from large data sets and can be used to summarize various subjects and interests of data. With the increased growth of data, with big data and so on, there are large and large amounts of data set that cannot fit in our Excel spreadsheets. Maybe a load time is a lot, or we have different sources of data or Excel files. So a data visualization can help solve this problem. Data visualization allows the user to be able to identify relationships and patterns within data. It also discover trends both in the business and in the market as a whole, which can help businesses get an edge over its competition. And also, various industries have visualization that compares competitors for better business insight. So, be it a competitor in the financial space, in the healthcare space, and so on and so forth. Data, there are public data which could be used to gain a competitive advantage by comparing what your competitor is actually doing or how they are marketing their products or selling their products and so on. And finally, we have data visualization is important to communicate a story to a business. It allows individuals to convey data-driven insights in a clear and compelling manner. And a well-designed visualization facilitates the effective sharing of information with stakeholders, decision makers, and the general audience. Moving on, so when we're doing data visualization, what are some of the key things that a developer, a business, or even anyone that is performing the data visualization development needs to know? So the first thing is understand the data that you are trying to visualize, its size, and how frequent the data is being received. This can help save a lot of time and allows the developer to make recommendations. Second thing we have is to determine what you're trying to visualize and what kind of information you want to communicate to the business. Third is knowing your audience and understanding how your audience process visual information. So some teams, be it the finance accounting team or even technology teams, some teams may have a set of way that they consume their data, metric tables, KPIs, executive KPIs, and so on. So understanding who you're trying to send that data visualization to is very, very key. And lastly, use a visual that conveys the information in the best and simplest form to the audience. And this can be by making recommendations to the business to provide them with more options to help them understand the insights. Next, we have the benefits of data visualization. So when a business uses data visualization, what are some of the things that they should look forward to? Number one is excellent consuming, transforming, and visualizing information on projects. So your visual representation simplifies complex data, making it easy for individuals to understand patterns, trends, and relationships within the data itself. We also have the immediate access to important business insights via interactive dashboards and reports. Visualizations make data accessible to a broader um, audience and including individuals who may not have expertise in statistics and data analysis. So these days we have Power BI and Tableau that have workspaces or like the server that can show data visualization on a mobile device, tablet, desktop, and so on. So it can be accessible anywhere. It's also great at identifying and communicating business trends. Visualization make it easy to identify trends, patterns, correlation within data sets, and to help organizations gain valuable insights into their operations. Then lastly, overall data visualization saves time by presenting information and data accurately and in a timely manner. Imagine having lots and lots of files or like a huge file of data that you need to prepare for some kind of report, monthly reports, weekly reports. data visualization can save you lots of time by exporting the data into the visualization tool and getting actionable insights immediately. So some use cases. Let's review some industry use cases of data visualization. One, within the financial industry, data visualization can be used for portfolio analysis. So this is to visualize investment portfolios to understand risk exposure and returns. It could be used for financial reporting, which is pretty much presents financial data in charts, graphs for easier comprehension. Data visualization can also be used in the healthcare space for patient outcomes to visualize patients' data, to analyze treatment outcomes and identify areas of improvement. It can also be used in the educational space for student performance and institutional analytics. So for student performance, we can visualize students' data by identifying trends, areas of improvement, and successful teaching strategies. Institutional analytics can analyze institutional data to make informed decision and resource allocation within the education sector. We have the government, which could be used for public policy analysis to visualize data related to public policy, crime rates, social justice, and to inform decision making, and also budget allocation to represent government spending patterns and business allocations in a visual format. And we have that within the marketing industry for campaign performance. So it could be used to visualize the success of a marketing campaign, including rates, conversion rates, and engagement metrics, and also be used for customer segmentation, which is to create visualization, understand customer demographics and behavior. Lastly, in the technology space, it could be used for system monitoring to visualize real-time data on system performance, network traffic, and user activity, and also error tracking to visualize visualizations to identify and understand patterns in software errors and issues. Data visualization it can be used for a lot more. It could be set where it's being refreshed in real time, meaning the data is updated, it's in the dashboard, or it could be set to refresh at time, whether daily, weekly, monthly, and so on.
All right, we're going to go ahead and launch our second poll question. So, are you currently using a BI application? If so, which app? Power BI, Kibana, Tableau, Cognos, Oracle Data Analytics, QLink View, MicroStrategy, Advanced Microsoft Excel, or not you currently using? Responses are starting to come in. Looks like most people so far that have answered are using Power BI, 86%, and then 14% are not currently using.
Sounds good. Thank you, Maddie. So moving on, let's review some of the leading BI tools. So some of the leading data visualization tools, we have a lot more, but some of the key popular ones are Power BI, Kibana, Tableau, Oracle Data Analytics, ClickView, MicroStrategy, Cognos, and Advanced Microsoft Excel. So Power BI, Power BI, So Power BI actually offers a wide range of flexible and scalable data sets. Power BI has a DAX engine that integrates data from data sources such as SQL, text files, the cloud, and many more. DAX assists in providing interactive data in Power BI data visualization toolkit. So some of the DAX functions that are very, very powerful, pretty much logics, datetime functions, math functions, and also within Power BI also has a Power Query, which Power Query can be used for ETL tasks, such as transforming data that comes in into what are the business requirements as far as be used to create relationships and also the data modeling aspect of things. Power BI offers interactive dashboards and reports, and these features include visualization ranging from tree maps, bar charts, line plots, funnel analysis, charts, and many more. These visualization types, which is the tree maps, bar charts, line plots, and so on, have their best practices. For instance, when dealing with time, obviously, yeah, you want to use a line graph to actually show trends over time. When comparing two different data sets, you could use maps, or even when trying to actually find an outlier, you could use like a scatter plot and so on. Power BI in general is one of the leading industry tools. Power BI is a business analytics service by Microsoft that provides interactive visualization and intelligence capabilities with an interface that is easy to use and end users to create their own reports and dashboards. So what you're seeing on the screen is a Power BI connection. So Power BI could be used in many ways. On the left-hand side, we have our different sources. So it could be text files, it could be from a SQL server, it could be from the cloud, and so on. So these sets of data sources are being extracted, which is the ETL that we talked about. Extract, transform, and load based on the business requirements that is being housed in the data warehouse. And that data warehouse pretty much Power BI connects to that, and it could be used for visuals. So these visuals can be uploaded to the Power BI server by giving your users access to the reports. You could use row level security to actually limit what a user sees as far as data is concerned, or be able to hide a more sensitive data to a specific set of audience. What's on the screen is an example of a Power BI report. So as you can see, we have KPIs, we have bar charts, combo charts, everything here with the different legends, different tabs, as you can see on the top. So Power BI, in essence, once the dashboard is developed, this can be pushed onto the web, which you can access on your phone, desktop, and so many other devices. So Tableau is also a powerful data visualization and business intelligence tool that enables a user to connect to various data sources, just like Power BI, to create interactive and shareable dashboard and gain insights from their data. So Tableau also, as we mentioned on Power BI, it also offers the market chart topping business intelligence tool that many other people, many businesses uses for the simple fact that it is easy to use, very drag and drop, easy to understand. Executives or non-technical folks can easily use it and be able to build visuals. So Tableau also offers secure sharing of data from sources ranging from premises, hybrid, cloud, etc. Just like we talked about Power BI, row-level security, you could also have data restrictions within Tableau as well. It allows the use of live and dynamic data to change data models in real time. So this is within Power BI, Tableau. There's the live and extract feature, which if you are on live, you actually have the data coming in real time, and extract, you could set refreshes hourly, daily, and so on to get your data at any time that you want. And in addition, Tableau supports data sources such as Presto, MemSQL, Google Analytics, Google Sheets, Cloudera, Hadoop, Salesforce, SQL Server, Dropbox, and many more, including text files. So as we displayed for the Power BI, this is a sample diagram of a Tableau connection. So what you have on the left-hand side is your on-prem files, whether it's CSV, Excel files, your SQL Server, and so on. You have AWS or cloud environment, and also like a public cloud environment that it can actually connect to, and you have your Tableau setting here. In my experience, the main difference between Power BI and Tableau simply is the actual data processing piece that Power BI can actually do with a Power Query. Tableau, a user can actually clean up the data within Tableau itself using other things like calculator fields and so on, but it is much more easier with the Power Query than having that done in Tableau. As we showed, this is a sample visualization for Tableau as well. So we have maps, we have bar charts, and so on. So Tableau can be used to customize a lot more visuals than this. Even though some of the visuals that are not displayed under the Show Me, you could actually have gauge charts, Gantt charts, and so on and so forth. And now Kibana. So Kibana is an open source data visualization and exploration tool designed for use with the Elasticsearch platform. It provides user-friendly interface to interact with the with and visualize data stored in Elasticsearch. So unlike Power BI and Tableau, Kibana connects more to and actually makes sense connecting more to the Elasticsearch, the user interface that is used to visualize and analyze Elasticsearch data, which is like the log data and so on. So it's also accessible through a browser, which is you could actually access it through a browser and actually be able to develop from there. Tableau especially also can be, there's a Tableau online, which a user can actually develop online as well, but probably better to use it on desktop for easier use and so on. Kibana Kibana server communicates with an Elasticsearch cluster to retrieve its data. So as we mentioned, the Elasticsearch, which we are not going to get into detail, actually gets data or retrieves data which is being stored in that Kibana can actually connect to and be able to visualize. So it also doesn't require any database management. Everything is being done in the Elasticsearch, so the data is cleaned and so on. Once it comes in, it's pretty simple, but it requires a little bit of technical expertise. Unlike Tableau and Power BI, Kibana does have a learning curve. So this is also a sample diagram of Kibana. So as you can see, we have different tools which you could get your log data from, which is being connected to the Elasticsearch. Then Kibana connects to it and visualize it. And as you can see, these are some sample visuals of Kibana that could be created. All right, so let's discuss the two comparison. First, we have the user interface. Tableau is known for intuitive drag and drop interface, which is more suitable for executives, beginners, and also advanced users. There's Power BI, which integrates well with the Microsoft product, offering a familiar interface for its users. Also, if you are using any Microsoft product, probably SQL is actually easier to integrate that by connecting to your SQL tables and developing it. It's also good for all the differences designed for the ease of use, especially for the organizations using Microsoft tools. So it's more easier, kind of gives you a lot more features. And also Kibana. So Kibana is primarily designed for users with some technical expertise, especially in Elasticsearch, and it may have a steeper learning curve for users without a background in data analytics. All right, so data source and connectivity. With Tableau, it offers a wide range of connectors for various data sources. It's good support for database, cloud-based data, and also big data sources. Power BI are very similar, also strong, also connect to different data sources by strong integration with Microsoft products as mentioned, and it supports a variety of data sources both on-prem and also the cloud-based. And lastly, Kibana, which is especially powerful when used with the Elasticsearch stack, even though it can connect to different data sources, but it's just definitely powerful using with the Elasticsearch. And is designed for working with Elasticsearch data, but obviously it could be extended for other sources. All right, now let's discuss the cost. So with Tableau, generally considered more expensive, especially for large organizations, and also the pricing may vary based on deployment options. So as we mentioned, Tableau Desktop, Tableau Server, and Tableau Online. Power BI, on the other hand, offers a free version with limitation and a subscription-based model for its customers, especially as we mentioned, using a Microsoft service already. You already have Power BI, which you can use to integrate other things and be able to use it for more productive things. And Power BI can be more cost-effective for organizations already using Microsoft products, as mentioned. And lastly, we have the Kibana, which is open source. It's actually its cost may be associated with additional features, but pretty much is an open source that can be used with Elasticsearch. All right, so now let's discuss best practices or lesson learned over time as we've used data visualization. So the first thing, several key lessons, obviously it can be learned, especially from as a new beginner using data visualization, you will definitely encounter a lot challenging things and learn a lot of things, a lot of good things as you move along. But some of the key things to learn, or some of the key things that we have actually learned using data visualization is knowing who you are relating your message to. Definitely that is key. So understanding your audience is definitely paramount. So different stakeholders may have varying levels of expertise and different information needs. So tailor your visualization to meet the expectation of your business. Also simplifying the complexity of the visual. So avoid unnecessary complexity in visualization, strive for clarity, and ensure that the main message or insight can be conveyed or understood without overwhelming the viewer. More than likely, as people get to use it, you could actually get excited by the things that it could do. You could actually build graphs that could overwhelm the user. So definitely simplifying it could be very, very helpful. The next thing too is to choose the right chart type. So as we mentioned, depending on what you're trying to convey or what kind of data you are working with, is definitely good to actually understand mainly the message that you're trying to convey and pick the right chart type that can convey that message. So as you select the right chart type, you could display different data relationships that are best represented by specific chart types like line graph, trends, bar graphs, and so on. So definitely choose the one that most effectively conveys your message. So we have next, which is emphasize on storytelling. So if you choose to, tell some kind of story versus actually displaying key metrics and KPIs, then the data visualization can be used to actually construct a narrative that guides the viewer through the data, highlighting key insights and trends. So a compelling story enhances understanding and retention. Definitely color matters, so be mindful of the color choices. Use a limited color palette to avoid confusion and ensure accessibility for colorblind viewers. So consistent color coding aids comprehension across different visualizations. I've seen a lot of the clients that we have worked with have a custom color palette. So marketing team or the branding team actually selects a color palette that can be used for visualization, which kind of set a culture or like a structure within the teams to be able to display our visuals in a consistent form. Definitely label clearly. So labels are essential for clarity. So label the axis, the data points, and any other relevant information. Ensure that the information is self-explanatory, reducing the need for additional explanations. You want to test your visualization. So one of the most difficult part of data visualization, or one of the key parts of data visualization, is the data. So the better your data is, the more tested your data is, the more comfortable you feel about your visualization. You can build a pretty dashboard, and if the data doesn't make sense, then it's definitely useless. So testing is definitely key. So don't be afraid to iterate and refine the visualization. So seek feedback from the users and stakeholders and be open to making improvements. Test your visualization with the target business and also help identify potential issues and areas of enhancement. So it is that developers' responsibility as they are working with businesses and stakeholders to actually make recommendations that can help them be able to pick the best visual. Then lastly, the data quality. So as mentioned, that is key. Ensure that data quality before ensure that data quality before creating the visualization. So inaccurate or incomplete data can lead to misleading visualizations and incorrect conclusion. All right, so let's pick an example of a data visualization or analytics strategy that we have actually implemented for one of our clients. So this is a finance team within an organization that uses various Excel spreadsheets to generate monthly and executive reports. These reports contains Excel formulas, functions that need to be updated regularly. So they actually export data from third-party tools like HCM, Salesforce, and many more. So there is an individual with the responsibility of extracting this data monthly and actually checking VLOOKUPs, formulas each and every month to ensure that it's been updated. And also a manual coding is involved in this. So the key highlight of this project is actually have the data in one centralized location so that Power BI can actually be able to connect to that environment, pull the data in, form a data model, and be able to visualize the monthly reports, which could be refreshed every month, and also helps save time with maintenance and so on. So the solution that was implemented is a high-level architecture diagram of the solution. So as you can see on your left-hand side, as I mentioned, various data sources. This could be text files. They could be coming from third-party tools, on-prem tools, or any in-house tools that has been built by the organization. So a process or an ETL process, which in this case, since the client was a Microsoft product client, we use SSIS to actually extract the data into a centralized location, creating tables, views, store procedures, and so on. Then from there, a Power BI actually connected, developed into Power BI desktop, which is then pushed into Power BI service, which is the server, and the user can actually access the reports on the mobile device, desktop, and so on. So this is a high level a solution architecture of one of the problems that we had to solve for a client. So it looks bigger than it shows, but it was a lot that was put into it to actually get into one centralized location and be able to view the visualization. That saves time. It obviously allows the business to focus on what it does better, which is actually continuing the business of the of the organizations and worrying less about updating formulas and so on. All right, so in summary, data visualization is an art and science of presenting complex information in a visual format, such as charts, graphs, to facilitate understanding and derive meaningful insights. By transforming raw data into visual representation, it enables individuals and organizations to identify patterns, trends, and relationships, making data more accessible and actionable for informed decision making. All right, any questions?
If you have any questions, you can go ahead and submit those to the chat or in the Q&A. But kind of to get us started off here, how do you ensure that your visualizations are accessible and easily understood by diverse stakeholders?
Yep. So basically, we measure success by the impact of the decision making. So obviously, if the visualization leads to a positive action, then we see it as successful.
Great, thank you. What do you think the future holds for data visualizations in your industry?
Definitely, I think AI-powered analytics will be a significant role in the future. So data visualization obviously is going to be assisted, or AI is going to be used to actually help that a lot, which is exciting because we actually um, getting lots and lots of data each and every day. So the ability to have AI technology be able to help in this is definitely an exciting thing.
Excellent. How do you measure the success of a data visualization, and what metrics or criteria do you use there?
Yeah, so I think the key thing, obviously, for a successful visualization is one, if it actually meets the requirements of the business. So there are some businesses that do have data that really do not know exactly what to derive from the data. In such a case, sitting down with the business, actually understanding what they're doing, what they're using the data for, is key. So being able to answer those questions with the data is a number one key of success, and also them being able to understand and actually make decisions from that result is also another way of determining the success of it.
Great. Thank you, Jesse. We had a comment I have to drop for another meeting, but this was great information. I have access to all of these tools in my organization, but I'm struggling to decide which to use. And yeah, we might be able to follow up with that person later on. But if there are no other questions, thank you all for joining us this afternoon. A recording will be sent out to those who attended here live no later than next week. Feel free to reach out to us, elire.com, and on our social media channels as well.
Sounds good. Thank you, everyone. Thanks for joining.